Asa loves thermistors. I drew a blue cloud. He's on a cloud. He's got his tongue sticking out. He's drilling.
You need to put a 9 on the flat. He's on 5 now.
Oh, that's true. Ish.
9-ish.
Not long enough. 9.
You still got a lot you can hear.
What are we gonna talk about, Caden?
Where did this map, subdivisions,
What are we gonna talk about? Speed density, phone number, I'm not sure what all that was. O2 sensors. We can talk about O2 sensors. Got a flow going this way. I don't know how to spell oxygen. Oxygen and HCs, hydrocarbons. Got an O2 sensor right here. And there's 2 wires go to the PCM. And then there's 2 wires that go to power and ground. One goes to power, one goes to PCM. Or one goes to ground. Yeah, one goes to power, one goes to PCM. So this one here is going to go to the PCM. And then this is going to go to 12 volts. Okay? How are these drawn? I usually had one up yesterday. It's basically a box. You got 2 wires here, comes down with a heater. Morning, Griffin. Morning, Wesley. And you got another wire comes in here, and it kind of looks like a thermistor, I think. It kind of just has a
Oh, so you know I'm gonna love it.
line through it. Okay. So it's checking for hydrocarbons and oxygen in the exhaust pipe. There's all kinds of stuff in here. It's going around the sensor. A lot of times these things have a little weird wiggy on the bottom. They got a little couple slots in them so the air can get through it. Hydrocarbons and exhaust going through there. Before an oxygen sensor works, it has to be 600 degrees before it'll start reading. I don't know why, it just does. Science behind it, but I don't really care. Has to be there. The old ones on a 93 car, 93 car, they only had 1 wire. In the exhaust pipe was the ground, and 1 wire shooting back to PCM was the, it just had to wait till the exhaust heated up 600 degrees. Well, that's not quick enough. Remember, they want to get the stuff, emissions burning quick, so they put a heater in it. So now the heater heats it up to 600 degrees so it can smell like, within like, those new ones are within a couple of seconds. Heats them right up real quick. So, if this heater gets broken inside there, like a burnout light bulb, which happens a lot, if that heater gets broken, it'll set a O2 sensor heater CKT code. I don't know the code number off the top of my head, but that's what it'll say. So in that case, it could be a blown fuse. It could be a blown fuse that's blown. It could be a broken wire between the, because the PCM pulls this to ground. So a transistor, how do you do it? Oh, transistor's like this, and it's got like this thing in it, like that, I think. Something like that. The PCM pulls it to ground. So if you break anywhere in this wire between 12 volts and the PCM, the voltage doesn't go through the O2 sensor and back to the PCM. There's actually, the reason it sets one is there's a comparator right here. We'll do it again. This guy is like, knows everything. He makes sure there's 12 volts there until it grounds. When the computer tells him that I grounded that, then he wants to see 0 volts there. Make sense? But if he sees 0 volts there and it's not grounded, he knows that either I got a bad fuse, I got a bad O2 sensor heater, or the, or the ground wire, the circuit wire, the control wire is bad. It sets that code. It's a very simple code. Circuit code, just like the variable valves, timing solenoids on the 2.4s that go bad all the time. Same kind of code, it just watches back there. So they have to have a heater, they have to have 600 degrees before they'll work. And then this guy here, once he knows it's hot enough, he'll start doing the duty cycle. On most new cars, they'll do duty cycle. Old Chevys, they just put them on and leave them on. But the duty cycle on the newer ones. So that anything in this circuit will set that code. So how would you test an O2 sensor? How would you test a heater circuit on an O2 sensor? Don't say it, you know, make these guys think.
It makes sense to me now why you do what you do. It just clicked with me how you test those and why it's so quick and why it works.
Well, what works?
What you do to test that
Okay.
heater circuit.
How do you test the heater circuit?
I'm gonna.
Pull it out and see if it's hot.
Pull on, see if it's hot? No, that's incorrect.
Put one to power.
How long did that take you? I can test that in like a minute or less.
Put it to ground and power.
Then what would you check?
Yes, you're right. We're checking the
If
heater.
it's hot, there's a really easy way to check that. Griffin knows, but he better not say.
Just feel around the.
Just feel around it. Can you get inside this thing and just feel if those wires together?
Yeah, of course you can. You just have to cut off.
Okay.
the pipe.
How would you check it?
I know there's like a cool trick there.
Of course there is. How would you check it? You know what that is?
That's a.
Your volt-
DVOM. Digital voltmeter. Okay, how are we gonna fix this? How are you gonna test it? How would you test a fuel pump? How would you test the motor to see if it's bad? How would you test the rheostat in the tank of that car? Morning, Joel.
Check the resistance.
Check the resistance? Okay.
But the main way I'm thinking of that would be you would have to check every wire.
How would you test, let's say we have just the oxygen sensor sitting here, how would you test just that? I mean, it's right here. I mean, resistance is good. How would you hook this digital voltmeter up to that to test it? I mean, leads to leads, right? So, this one go here, this one go here, and you would do, check the ohms, right? What's the ohm meter gonna read with that broken like that? Out of limits. Okay?
That's what you do.
Mm-hmm.
That's your trick.
Yeah. I think he's mad that it's so simple, right?
It's not a trick. I was thinking of something like more elaborate than that.
I was like,
It's a broken light. So I'm like, why are you guys not getting this? It's a broken light.
I was all
Burn out
having
light
to,
bulb.
like, no, there's
Sci-fi
another, you
light.
use a Davies trinket to test the circuitry on the other
Well,
side too.
Yeah.
That's why you use the Davies
This is
trinket.
how you check this. You can't really check this because it only works off of oxygen, so you can't really check it with an ohm meter. Not that I know of, anyways. But so you check the ohms, the ohms on that. If it's good, it'll have like, again, how much work does it have to do? The more work it has to do, the newer the car, the lower the ohms because it works more and it heats up faster and it gets less emissions up the tailpipe. Kind of dumb, but that's how it works. So the old ones would probably be like 20 ohms. I think some of the new ones have like 8 ohms. Up, down to like 8 ohms. But they run really low ohms so they can run it 100% on. And then once it heats up, they duty cycle it. So they still are only taking a certain amount of power to run it, but they duty cycle it so that they can get it quick, but then they can maintain it with duty cycle. Make sense? I have a little box of trinkets up there.
You showed me those yesterday.
Okay. What they do is, basically there's a connector, so you pull the connector apart, and I have the connectors off O2 sensors I've taken out, and I make these little things. What it does is, this will typically have, there's another comparator in here, but this guy will typically come in here, and then this thing, talk to this comparator, which you can talk to on the scan tool. This is, usually if you unplug an O2 sensor, 450 millivolts, half a volt. And this here would go to ground. So I'll put a ground there. Okay? So what I do is, I learned this in the class. You take one of those things and you make it so you plug it in, and it literally just shorts these across. That 450 goes down to 0 on your scan tool. So this would go from 450 to 0 on scan tool. That does a couple things. You ever have a car that has 4 oxygen sensors on it, when you plug that in and that goes to 0, you know for a fact that bank 1 sensor 1 is the one you plug in. There's no confusion that you could be on bank 2 or bank 1.
So it isolates.
When you plug that in and it goes to 0, you know that what you're looking on scan tool, what the scan tool is calling bank 1 sensor 1 is bank 1 sensor 1. That's the first thing it does. You know, no confusion, because sometimes, well, which side's bank? I think it's the front, but it might be the back. And you replace the back one, then you end up still having the
You
same
can't look
code.
that up on all data.
You can, but is the information ever wrong? That will basically be never wrong. Second thing, we could have a blown fuse, right? We have a bad wire, blown fuse, whatever. So in this same thing that I made here, I have them up in my little box up there, and we'll look at that sometime. That looks like a resistor, but it's a light bulb. Put a light bulb on. You plug it in, it goes to 0, your light bulb lights, you know all your circuits are good, and you replace the sensor and you're done. Okay. Done. Super quick.
So it essentially it isolates it.
So this here is my tool right here.
Oh yeah, you showed me that yesterday.
Yeah, that little thing that had a light bulb on it, yeah. Some of these things, generally just actually was on the car I worked on the other day. This thing here, you actually have to take it to ground before it will go to ground. I don't know why that is, but there's one GM that has to be that way. But does that make sense? You guys have any questions? So hit me with questions. I want as many questions as possible to make my job easier. Makes you guys learn more. No stupid questions. So right now, would this light bulb light up? When this guy went to ground, would this light bulb light up? Why not?
Yeah.
Broken.
Okay. Now, how about now?
Yeah, it should.
And you can also go in the scan tool and functional test, and you can command the oxygen sensor heater circuit. You can bidirectionally control it. And you can make that guy turn. You can make this guy turn that on. Pull it to ground.
So if
Trying
you
to
put
test
that
it.
light bulb in there and it doesn't light up, and you check all your wires and they're good to the light bulb and all that good fun stuff, then the sensor can still be bad inside.
If this does not light up,
Yeah.
that has to light up at some point. If that doesn't light up, you got a blown fuse. You don't have 12 volts. You don't have a good wire here. You don't have something.
Okay, but what if you have good power to the light bulb and you have
Okay.
good power to the sensor, but your light bulb still don't light up because the sensor's bad? No?
We have disconnected the sensor. The sensor is no longer in this picture. Right here, see it's disconnected?
Then what's your little box up there? Is that the PCM?
This thing?
No, over. Yeah.
Yeah, it's a PCM.
Okay. I got you.
Sorry, I didn't write PCM.
I was a little confused.
Did you just wake up?
Like half an hour ago.
Half an hour ago?
6 a.m. is pretty early, man.
Well, 5:45 is pretty early, I know. When I get up.
I look like a half an hour away from him and I get up in 15 minutes.
Any other questions about these? So
I
that's
kind-
yeah.
No, I see what he's trying to ask, and now I'm kind of curious about it too. So if that light doesn't light up and all your wires and fuses are good, then does that mean it is you're saying it that it's definitely the fuse?
Well, if this light doesn't light up, I'm going to check power here and ground right here. Because if you have power and ground here at the same time,
Yeah.
it will light up, or else the bulb dead. So if it doesn't light up when I plug that in and command it on PCM by bidirectional controls, or functional test is what they call them. Sometimes, like most Snap-on scan tools are going to say functional test. If I command that on and it still doesn't light up, and I know I have power here, it could be this little transistor in the computer. I've never replaced one. It could be that. You could have a connector here with corrosion coming out of it. You have bad wire. Morning, Andrew. Does that make sense? But if that lights up and this goes from 450 to 0 when you plug it in, and it's got a heater circuit code, you know 100% that you have the right sensor and that you have the right sensor and that the heater circuit's good here. But this would be my go-to test. So on almost all oxygen sensors, the two heater circuit wires are the same color. So if you got two, and it goes up to the connector, right off the back of the sensor, both of those are the same color. And this one here, a lot of times will be a different color. Those two will be a different color. But the two of them that are the same color, like usually there are two white ones or two black ones. Let's see if he has one over here. Good for on. Here it is right here. See those two brown ones? If you measure those two brown ones, you'll get the ohms. That's a heater every time. Purple probably the same. On oxygen sensor, whatever the two are the same color, they are, they are the heater circuit. This one here just wouldn't. It stayed at 0. Like it was dead. But it lit the light up. I plugged that one in, and it lit this light right up. And once we grounded it, because it was that kind, we had to ground it. Once we grounded it, it went to 0 on the scan tool.
So we're hooking it to these two right here, right?
Well, that's right here. Yes.
And we're just gonna go right here.
Ohm
with
meters.
this.
Yeah. I don't have an ohm meter here, but if we did, we could check it. Find out how many ohms it is.
And then where would you find the certain ohms you're looking for? What's the range?
It might be in the diagnostic flowchart for this code. I don't know, C103 maybe would be a code. P103, P0103. Might be, I'm not sure if that's an oxygen sensor code or not, but it'd be in the 100 probably. Just what comes out of my head, I could be wrong, but I think it. Because if it don't heat up, it can't tell this. Anything that raises emissions has to turn the light on, but if it doesn't raise emissions, it's optional. If it raises emissions, it has to turn the light on. He's getting an ohm meter in. Morning, Daniel. Good times?
Hey, remember that one time when we ran out of gas and decided to do and they called the air cleaner on fire? Me too.
Yeah, I didn't set on fire though, so.
Where does the gas tank go?
Up there next to the white shelf, I
You
think.
set it by my blue trash cans out there.
Fuel gauge works though, right?
I don't know if you.
Ohms, and you can go back here too. Here, you got a back probe, the back probe two right here, the same color, two top ones. Usually they're right next to each other. So back probe that one, back probe the next one. See what you get. Out of limits,
Allegedly.
allegedly. So it's something to always check in here, check your leads, like this. What's it say? What's it say? 0.4? So you check your ohm meter to make sure that ohm meter is actually working correctly. So this one here, let's go this side. On there, and is it really out of limits?
Doesn't actually open?
Yeah, it is actually open. It didn't set a code for it though.
Oh, really? 'Cause that's what I do for my tests, is you know, have the heater code. Whoop. Okay, that's what I've always done. Out of limit.
Yeah, so
don't
this
go.
one's out of limits, right there.
That's actually, I'm amazed they didn't flag a code for heater circuit. What was that on? This?
No, it was on that Impala Jeremy was working on. It was stuck. It was stuck
Yeah.
low. You can check it. I don't think that's nothing there. See, that's checking the other side of it. It's out of limits there too, but that has a burnout heater in it. So we don't have one on the shelf in there, do we?
Yeah, there's a couple of them.
NTK right here.
There you go.
Let's see if this one here works. So literally, this is brand new, so I'm not gonna I'll poke to the back here. See two white wires? I can get a reading on you real quick. Nobody will ever know. Two white wires. 6.2. So that's really low.
He's not man.
Yep. 6.2 ohm. There's no M there. See, there's no M. There's no K. So 6.2 straight ohms. That sucker will light quick. Lower ohms, a lot of work. That thing will get hot real quick.
So it's a, okay.
Make sense?
Yep.
So that's a good one. That other one was bad.
Back probed it.
What's that?
We back probed it.
We did back pro. What do you guys want to talk about now?
Lambda.
Oh, lambda, really?
No, negativity.
I don't think we want to talk about lambda yet, do we?
I'm very curious, so we can save it for next week though.
Do you have any other questions about oxygen sensors? Not really? You can go back and watch it on the thing. I'll try to upload it. This is Asa. He loves thermistors. He's hugging it. He's on cloud 9-ish.
There could be something better.
I know. They don't erase. Oh my goodness.
Yeah, we got to erase it.
No.
Yeah, it's gone. You can cry later. You can call your mommy later. Okay, what you got? What are we looking at? What we need to do? What we gonna do? Max airflow? Map sensor basically is gonna look like exhaust. We got stuff going through here. Okay, yeah, maps are kind of interesting. So they have mass airflow sensor. It comes up here like this. It's got 3 wires coming off of it. So 5 volts, SIG, and GND. Ground. Then it goes in this pipe and it has a little guy who's down here. And he's got little wires that go across. I think they have at least 2. They probably have 3.
Is that a resistor?
Kind of. Okay, so that's a mass airflow. All 3 wires, I think, go to the PCM. No, I'm gonna do a GM 3800. I think one of them goes to 12 volts. So the fuse. And other 2 wires go to the PCM. Ground goes in and goes to the ground. Okay, so we got airflow this way here. This thing here heats these wires up to 300 degrees. Okay? Okay? That heats those wires at 300 degrees. It keeps those wires at 300 degrees. So what changes when you blow air through there?
It's cool.
They want to cool down, but if I have to keep them at 300 degrees, and basically it's a heater, but you're trying to cool the heater, so you're making the heater work harder, it draws more amps. It's minuscule, but it does. More flow, more amps. So it probably has another one somewhere that's not, let's say this one here is blocked off, so I can't see this one. It says a reference. So there's no airflow on this one. But there's airflow on those 2. If it knows what no airflow looks like with the same little heater circuit, that stuff flows across here. You keep that 300 degrees, the amps goes up. The higher the amps, more airflow. That make sense? So this here would have a comparator in here probably. Little guy. And he says if it takes, let's say, 300 milliamps equals 50 grams a second. He knows that signal, whatever that is. And then this thing here puts out a square wave. Like that.
Is that a duty cycle?
Yeah, parts. Yeah. But this one here, instead of the duty cycle versus parts, there's a difference. Duty cycle, let's say it changes 1 millisecond. What?
You want to get the element higher so we can see it.
Yes, it's loud. I don't like it. So every one of these is 1 millisecond. Here. 1 millisecond. Parts is how many times it changes. It's probably 50% duty cycle. The hearts is let's do 1 millisecond, and then all of a sudden we're going to hit the throttle, and it's going to go like this. We're going to let off the throttle, it's gonna get bigger.
Yeah.
And I'm gonna shut the car off and it's gonna get really big. 'Cause there's no airflow thrown. Does that make sense?
Yeah, it's basically.
This is how much on time there is. This is how fast the signal goes. Make sense?
Absolutely.
So advanced airflow sensors on 3800 work this way, not this way. A lot of times this is if you're controlling something, you can control, because you could vary the hearts, and as long, like these are all 50% basically, half the time they're on, half the time they're on. It doesn't matter how fast the hearts is, you're still gonna hold the sensor on, or the solenoid on the same amount. This here, if we vary this, so let's say these are still 1 millisecond, but we're just on for a little bit. That makes sense? This is gonna be the same, but then so this is duty cycle, and this is HD hertz. Make sense? So mass airflow goes through here. It has to keep that 300 degrees. When it takes more amps and gets up to 300 milliamps to keep that 300 degrees, this comparator right here knows that's 50 grams a second, which makes that go, let's say, 104 HZ, I think, would be what you would see on an idle. But it also, you can probably get the hearts, or you can also get, 50 grams a second on your scan tool. You can probably get either one of those on a scan tool, on a GM, like a 3800. So if I plug my scope into it, we'll get into the scopes more later. If I plug my scope into it here, between ground and here with the back probe like he had there, plug the scope in there, you will get this signal. And if you snap the throttle, if this is an idle, and you go boom, a whole bunch of air rushes through there, and it has to keep that warm really quick. It goes up to 50, so idle's like 4 grams a second. The idle, like that car is right now, it's probably about 4 grams a second. If you smash the throttle, that thing opens and all that vacuum just goes, rushes in there, and it'll go really fast, back to slow, and then if I shut it off here, that makes sense? Questions?
So if you start the car and you pull that sensor out, it'll be red hot.
No, they only go 300 degrees, it's not red hot. But what happens though is, you know why a dirty mass airflow sensor screws it up? Do you know?
Not 100%.
A dirty mass airflow sensor, the dirt insulates this thing. If it gets really dirty, it insulates it. How much air does it now take to keep that at 300 degrees? It takes a lot more airflow because it's insulated to keep it at 300 milliamps.
Yeah.
So it lies. It lies. Because you insulate it. It's the same as if you kind of covered this part ways up. So if you like to do that kind of thing, if you like to lie, I like to lie to it to make it lie to my computer. So if you actually take something and block this off, what did you do to the air going through here? Instead of having a big area, it's smaller. How fast does the air travel? A lot faster. I've done that. If you think you have a bad mass airflow, and you can cover the bottom of that thing, bottom third of it with duct tape, I've had cars that wouldn't hardly run. I went out and drove them, they were fine. But you have to still replace the sensor because it's garbage. Or in the case of like a lot of GMs, you just clean this stuff back off. Clean that back off. He's happy again. So this affects, a lot of times it'll affect fuel trim. Will be majorly positive. If that's clogged up. And also, if you go wide open throttle, it goes into open loop and it doesn't look at, remember I had all those things up here? It doesn't look at the O2 sensors in wide open throttle. It's called WOT open loop. It doesn't care about the O2 sensor wide open throttle, I don't know why, but it just enriches it, throw a bunch of fuel at it. But if you have a bad mass airflow sensor at wide open throttle, the O2 will be low. Because it'll be running lane because it's lying right here. So I've had them that wouldn't even hard to take off. You get a 4.3 Chevy or a 5.7 Vortec, and you stomp on it, and some of those things like those twos will go almost to zeros, and they won't hardly take off.
Why would a bad match in those things would cause it to like idle at 2 grand? Like 2,000 RPM.
Should.
So what happens if one of those wires in there breaks?
Don't touch them either, they're really brittle. We're not the hard way.
What?
So don't touch them either, they're really brittle.
You can clean them, but you have to use brake clean with a like a camel's hairbrush and just barely touch them. They're really easy to bend.
Yeah, I bet the one.
You can bend them, you can bend them back, it's still weird.
Really?
Yeah. You break them, they're done. Yeah,
I just thought if they got tweaked at all.
if you get a break in there, if you know what you're doing, you can just bend them back and make sure that everything is working right, and you're still good. If it works, it works. If it doesn't, it doesn't.
So if I get that code, I know my first thought is.
There's a lot of different things that can set that code.
So, but one.
This could be lion. It could be lion. It could say in an idle, this is 1 gram a second. Because, let's say, let's make this flow the opposite way. Let's say it's going this way. Doesn't really matter. This goes down to your throttle, and then this goes to your engine. What if there was a hole right there after the throttle plate and it was sucking a ton of vacuum? How much air is going through there? Less. And it's gonna lie. Right?
So I guess the better question would be.
Or the PCV valve is off.
So I guess the better question would be if you read that code, what are you going for? Can you take us through your process? What are you going to
If I read that code, I'll probably go look at history and see if it's set at an idle, see if it's set going down the road. You can look at code store a snapshot. So that would be, what's that called, I guess? Code history, freeze frame. Yeah, freeze frame. There's a song like that, isn't there? Freeze frame. I don't know what that. Go to freeze frame, see if it was an idle. If it's an idle, let it sit in idle and see what this is. If it's 1 gram a second in idle, fuel trims are really high, I'm gonna know that you got an issue there. 101 code, you could have a leak there, you could have a dirty sensor. 101 code is not a circuit code. It's a circuit as in the signal, but it's not a CK key open short, open or shorted. That code would be like literally if these were shorted together. Make sense?
Yeah.
Or the signal circuit was open, one of the two would set the circuit open or short code. Or if, it could be shorted in here too, it doesn't have to be shorted outside. Make sense? Other questions? Mass airflow, that's about as good as I can explain it, I think. And obviously, if the fuse blows, it's not going to work at all, because there's going to be no signal, there's no 5 volts to originate the signal. I put 5 volts there, that's probably 12 volts. So if I was to hook the lab scope up to it, I'd have a lab scope, I would have 2 channels, one for voltage and one for the square wave. And I would hook it to one of them to here, one of them to here, and one of them in the ground would go, power here. So I would hook all 3 of them into the scan tool, the actual lab scope. We'll do that later. And I would check to make sure that I have power and that I have a consistent square wave.
There's no way to check with the multimeter.
Not very good. You can also look at hearts on your scan tool. Obviously leverage the scan tool right away as much as you can. Look at hearts and grams a second on your scan tool in the data list. The old GM 3800s, if you take them right here, they go like this. They literally do. If you slap them, take a screwdriver and smack them, you can flip them. If you take the connector and pull up and pull down, the car will go garbage in, garbage out. You fed it the computer garbage, it produced garbage. Shut your injectors off. Literally, that's a test. Like, okay, we got bad mass airflow sensor. Just obviously it dropped. No, that actually happens. So this will just probably what would happen. It would probably stay low. And it says there's no airflow going through there. It's going to shut the injection pulse way down and stop it. So, next question. There's no dumb questions.
Now I'm just ask a dumb question.
Yeah, ask a really dumb one.
I can't think of it. Okay.
How does a cat fly to the moon?
Out of a can. Jeff Bezos could make that happen. What else? We covered a lot of stuff on mass airflows or fuel trims yesterday. I think the system's in the car. Morning, Todd. What are systems on the cars you guys want to talk about?
EGR.
EGR? Okay. What's EGR stand for?
Exhaust gas research.
Okay.
Sorry, I didn't catch that. What does it stand for? Stand for? I didn't catch that.
Exhaust gas recirculation.
Okay, this is an engine, intake, and put a little thing here with the throttle limit. Alright, so the exhaust pipes, obviously there's 2 pipes to them. So EGR comes up here, and I don't know if I can draw the actual EGR thing, but goes like that. And this goes here. And you have a little motor here that, let's see here. It's got a little thing that comes down here and it blocks this off. So it blocks that off, and then if it opens, it lets exhaust gas come in here. It lets the exhaust gas go out there. Does that make sense? Exhaust gas recirculation. So the vacuum here, because the throttle's closed, and then pistons are sucking, and then there's vacuum here, and then it just allows however much to draw out of there. That make sense?
There's no electronic valve.
It is. I haven't drawn the electric part yet. Make sense how it works though?
Yeah.
I'm gonna draw this big so I can illustrate it. Really big. Now these things are just like that. It's all about. Okay, so I have to draw a 3-wire throttle position sensor and a. They're 5-wire altogether, and okay, so I'm going to draw up here, and then this is there's 2 wires that run the this is basically a magnet. One goes to 12 volts, one goes to the computer. Okay, and this would be to the transistor, the ground. Make sense? This is a big piece of steel right here. When this turns on, it lifts that up and exhaust gas circulates. Does that part make sense? You alright, Andrew?
Cold.
You're cold. It's too bad we have air conditioning.
I know.
We can always turn it off, don't worry.
No, I ain't gonna complain. You asked, I told.
So that's gonna, when you ground this wire out, that pulls that up and it makes it turn off. Now, there's a little more to this. Let's say there's a pivot point here. This comes over and there is this is a resistor like the TPS was. This goes to ground. This goes to 5 volts with the regulator. Remember what the regulator looks like? That. And then there's a signal wire. I'm just going to take it off of here because as that moves up and down, it would change it. Signal wire goes to here, goes in here, and then it has this little dude looking at it again, the comparator. We need to make a name for the comparator. He's looking to. Make sense? So we got 5 volts here, 0 volts here, and as this moves up and down, this thing moves and changes the voltage of that. Make sense how we did the thermistor the other day? Same thing, same exact thing. So let's say the PCM starts coming in and I want, how does it do it? So this resting would probably be 0.76 on a GM, and then full would be 4.25 probably. Fully open 4.25. This is a closed loop system. Remember, information in, information out, information is just closed loop system. So it wants to go, let's say it wants to go to 1.2, okay? So this guy would start firing this and start lifting this. And as it lifts it, this is going to change right here. And it's going to change the voltage on the signal wire right here. That make sense? This is going to rub at a different spot in there. So it does, okay, it starts out 5%. Nothing moved. 10%. And it goes up to from 0.76 to 0.9. 15%. It goes to 1.1. 18%. Goes to 1.2, and it says, okay, we're at 18%, so I'm going to hold it at 18%. And then let's say it happens to jump up to 1.4, and so what it does is it backs off the duty cycle right here, which this is a duty cycle. Make sense? It backs that off to like 15%. To get it to 1.2, and then it goes to 1.1, and it goes to 18%. It just keeps working it to keep it at 1.2. This guy's job as a PCM is to keep that at 1.2 if that's what the executive wants. He's got a big head. If that's what the executive wants, if the executive wants 1.2 at all the different criteria we had here. Usually it's like light throttle. If he wants 1.2, its job is to vary this duty cycle to keep this at 1.2, and that's what it does. Sit there all the time you're cruising down the road. What kind of vehicle do you have?
Chevy Impala.
What year?
2002.
2002 Chevy Impala. It has this exact system on it. You have a Toyota. It uses VVT, and so it overlaps the cams.
You want to know what I have?
TDI?
Huh?
A TDI?
No. No 630 man, so we took that shit off of it.
But it had this. It did, and it looked in circles there.
Now it's like.
Does the diesel work the same as the gas one? Pretty much.
This part works the same.
Now, does that it stays open at the 1.2 the whole time? It doesn't vary, like it doesn't open.
Oh, it
close,
depends
open,
all on this
close.
criteria. It varies totally different. If you have lower vacuum, more of a load, it's probably going to open that more because there's going to be less different
But
pressure.
it stays open at some point. It doesn't like do a signal where it's closed, open, closed, open, closed, open.
It runs this fast enough that this virtually stays the same place
Okay.
because it's a really fast signal. But yeah, if it didn't, it'd be like.
So when
That's EGR you're talking about, right?
Yeah.
Yeah, if it sticks open and you come up to the stop,
It does.
it does.
Or it goes.
Or it's really, really
Sounds like it's got a massive cam in it. Because it's doing the same thing as a massive cam. A massive cam recirculates exhaust gas because on top of the center they overlap. They overlap more and more. And it recirculates exhaust gas. But they do that now intentionally with VVT. For valve timing, yeah.
Why do you want to use the air from
combustion a little bit, and it stops the fusion of two gases and makes NOx. It stops the NOx gas. NOx. I don't know what that is, but the bad
There you go. There's another good topic. NOx sensor.
NOx. Okay, yeah. They're actually pretty cool. I like NOx sensors.
Is that like me with thermostats?
A little bit, because you can actually knock on them and get a reading out of them. You had a question. What was the question?
Oh, I was just like, say, I don't know if the Cobalt has one, but every now and again I'll start it up and it'll do that. What would be, and like I can hit the gas.
Cobalt doesn't have it, but it has those two. Remember those two things on the top that goes bad, the BBT solenoids?
Not mine.
What year is it?
Oh wait.
It's got that.
Nope.
It don't.
The 09 I bought does.
Oh, it probably does have this then. If it doesn't have the two solenoids on top, it probably has this. But your 09 uses those and it just overlaps it. Morning, Mike.
So what? It basically does an EGR inside the cylinder with the valves.
Yes. The last part to go out actually is the most effective, so it pulls a little bit of that back in. And then it pulls intake in and charges it, and bang. Morning, Burton. Does that make sense how it works? So, how would you test this?
Oh shit. Yeah, that's a little.
I was just trying to figure that out.
It's really simple. Split it right here. Split it. How would you check that magnetic coil? If you unplugged it, how would you check that magnetic coil? Make sure it wouldn't burn out. How do you check a light bulb? How would you check the O2 sensor?
Okay.
With what? Ohms? Yeah. So you just hook your ohm meter up. Go one goes to here, one goes to here. And I don't know what I've hardly ever checked that, but it's probably like 5 ohms. Probably 5 ohms, because it has to do quite a bit of work. It's pretty decent spring there. Has to do quite a bit of work, so probably 5 ohms. How would you check this?
Same concept.
Ish. I mean, you could go between these two and make sure it had some kind of resistance. It wasn't completely open between the 5 volts and the ground. You'd have to unhook this. You could make sure that it does have 5 volts, so you could hook your voltmeter here, and you could go between here and here and make sure it does have 5 volts there, because that's coming out of the computer. You could do that, make sure it has 5 volts. We'll say it has 5 volts there. What happens a lot of times is this thing here where it rubs. After you rub on something enough times, it builds up a nasty, like, this thing's like a carbon track, they call it. And after you rub it enough times, sometimes they don't make a connection in a certain place. And actually what happens on these things, on the older days, this thing would change, and it would have a bad connection, and it would feed this guy bad information about where it was. Guess what he would do? He would feed this bad information, so it would go, it literally would just sit there and flutter, because that thing was doing stupid stuff. It was doing a bad thing. It would literally, there we go. You would put take a scan to it, go 10%, 15%, 20%, and you smack them, and they go, and it stop.
Is your fix to everything slapping it?
Slapping it, PCMs, you can slap them. Electrical stuff, you can slap it. You can make it cold or you can make it hot. Or you can bend it. You bend it a little bit and it stops.
The Holy Trinity.
Yeah, the Holy Quadrinity. Like those mass airflow sensors, literally, if you take not even on the wires, if you just take the corner of it and pick up on the actual plastic, sometimes they'll go and die. If it does that, you know it's bad.
The sensor, couldn't it be the connector type thing too? Wires?
Well, you're kind of picking up on, it could be, but make sure you got good pin fit and make sure it's clean. If it still does it, then you got a bad one. So then you could also go, from there to here to make sure that you got, make sure it's varying. You can take a screwdriver when it's just sitting there. You can push that thing open and shut and make sure it goes, from 0.76 to 4.25, and make sure it's consistent. If it drops out, if it goes if you do that and all of a sudden it drops out to like 0, you know you got an issue there. They can also get stuck where a piece of carbon will get in there and it'll stick them. You look tired. Tired? You good? Look like you having to wake up.
Kind of looks like you ran out of gas this morning.
Almost like you ran out of gas.
Too soon.
There's no fuel gauge.
What other question you guys got on that?
What happens if on the top where you're measuring the ohms, what would be the case if it was exceedingly higher than you want?
You go back.
If you had 30 ohms,
No, you don't. Shut up, don't sleep.
could you do enough work with 30 ohms?
Could you do
It works. It has to work pretty hard to pull it up. But you think 30 ohms would do much? I mean, that's like a light bulb. Maybe it's like going to produce almost no work. I think 30 ohms is probably bad because even those little BBT solenoids, they have between 25 and 12 ohms, I think, and they just make a little click a little bit. So if that was 30 ohms or OL out of limits, if it was open, it's bad.
Okay. What would be the cause of that?
Somebody cut that. That would cause it.
Is that the only possible scenario?
Well, it could be shorted, so it could have 1 ohm. It could be shorted out. If it had 1 ohm, I don't think that'd be correct. If it had 1 ohm, they would see this guy here drawing too many amps. So it'd be 12 amps. And he would say, no good. He said, go for it. Short to the ground. Make sense? More questions? Engine cylinder? It does. It pulls up carbon monoxide and then it doesn't burn as hot. And then it doesn't allow NOx gas to form because it doesn't. What is it? 2,000 degrees it forms? Do you know?
NOx gases?
Yeah. There's 2 gases that form and create NOx gas. I'm not sure. It has to heat it below like 2,000 degrees, doesn't it?
How about in the catalytic converter?
No, in the engine for the EGR. We're talking about EGR.
Oh, okay. I don't know.
It's something like that. If it burns low enough, it don't form those.
And this is all before the O2 sensors.
Yeah. O2s would be, you get your collector pipe right here and the O2s would be right here. It also goes back there as well. Now, if this opens and puts exhaust gas back in here, is this going to see more or less oxygen? Less or more? You're dumping carbon monoxide in here, so is there more or less oxygen actually coming through the throttle plate? Less? Yeah. So if you open that thing up, this is probably going to go from I don't know, 400, 410 millivolts to, 100 maybe, something like that. On the old days, in the Chrysler 3.0 liter, where they had a whole stupid system, they would actually monitor this really good in the PCM to make sure that that thing actually would drop when they would turn that solenoid on and off. Because they just had a solenoid and a back pressure sensor and that was really stupid.
That's a shocker.
Yeah, no, it was.
I smell something burning.
Yeah, you smell something burning?
It's probably that car.
Oh, it's not in the paper on the new Cadillac.
Oh, yep. Does that thing smell like it's burning at you, Leslie?
Yeah, it's got a sticker still put
Yep. Make sense? Any other questions? So exhaust gas comes out this way. Boom, 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 boom. Goes through this little guy based on how much that magnet's running. Goes in here. Goes back into the pistons. Gets ignited with the spark plug. Goes boom. Goes back out through here, and part of it goes back and recirculates again. Exhaust, gas, recirculation.
Closed loop, right?
And then this is a closed loop. Based on this feedback, the computer, it puts more or less here, to feedback this, the computer put more or less there, feedback this. Whatever this guy's calling for, whatever voltage this guy's calling for, 1.2 volts, it feeds this until 1.2 volts. That make sense? And you can pick these here on the scan tool, on the bidirectional controls. You can pick what you want it to be. Make sure it'll go there and stay, and go there and stay, and go there and stay all the way. You can make sure it goes up and down nice. If you get to one spot, it goes, blah, 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 blah. you know it's junk.
When you smack it,
And you smack it and it stops, it's junk. Make sense? We're out of time.
What is that?
Yeah.
It's the exhaust.
What?
The system.
EGR.
EGR, yeah.
EGR.
First step, just remove it. Makes it a lot easier.
Yeah. You just told me not to.
Well, you need to listen to it. Everything I own, absolutely.
Exhaust gas circulation. Make sense?
Yeah.
Okay.
Thanks, Marty.
Have a good day.